Hey everyone, it's Mr. Prevet. Excited to be back doing some calculus FRQs. Today we're looking at the 2022 FRQ number 3. We're going to be looking at the graph of a derivative, determining a lot of different things based on that derivative. So it should be a really fun time. I'm excited about it. So let's dive into it. So the question says, let f be a differentiable function with f of 4 equal to 3. On the interval from 0 to 7, the graph of f prime, the derivative of f, consists of a semicircle and two line segments, as shown in the figure above. Part A asks us to find f of 0 and f of 5. Okay, so let me do my best to sketch out this function. So we have this semicircle from 0 to 4, and a little triangle down to there. Now, let's work on it. So part A, it wants us to find f of 0 and f of 5. Now, let's think about what we could figure out. The first thing I could find is a definite integral of our derivative, because this is a graph of f prime, right? So for instance, if I were to do the integral from a to b of f prime of x dx, this would equal f of b minus f of a. And this integral right here will represent the area under the curve over this interval. And then f of b and f of a are just 2 points, which we might want to solve for, right? So what we can do is find the area under the curve from a point that we know, maybe a, to help us solve for f of b. Now the point that we know is that x is equal to 4, because we know f of 4 is equal to 3. So my integral from 4 to 5 of f prime of x will equal f of 5 minus f of 4. And the great thing is we already know f of 4 is equal to 3. And I can solve for this integral because I know it is the area under the curve. Obviously, this graph isn't perfect, but that's x equals 4. X equals 5 is right there. And it creates a triangle with a base of 1 and a height of 1. So the area of this triangle is 1/2. It's above the x-axis, so that means that the integral from 4 to 5 of f prime of x is 1/2. And that will equal f of 5 minus 3. I add it over, and I get f of 5 is equal to 7/2. And now I can do the exact same thing for my other point. This time I'll go from 0 to 4, because 4 is the point that we know. I forgot my dx on the first one. It's also worth noting the reason I choose 4 in the second one in terms of 5, even though I know the value of f at both of these points, is just because 4 is closer. It'll make our area approximation easier to do. So we know this is equal to f of 4 minus f of 0. So now this integral, right, is going to be the area of this semicircle, which has a radius of 2. Formula for area of a semicircle is 1/2 pi r squared. But this is below the x-axis, so that integral is going to be negative. That will equal f of 4, which is equal to 3, minus f of 0. Simplifying this out, one of those 2's will cancel out, and I will get 2 pi. So when I add it over, I get f of 0 equals 3 plus 2 pi. So that is our value of the function at x is equal to 5 and x is equal to 0. So not too bad overall. Not really seeing any issues there. So that is part A. A little bit difficult, honestly, finding these 2 points, but I think it could be a lot worse, right? That one's also worth 3 points, so it works out pretty well for us. But let's move on to part B. We already got a third of the points, so we're moving at pretty solid clip, you know? Part B says find the x-coordinates of all points of inflection of the graph of f for x's between 0 and 7. And it says justify your answer. Now, points of inflection, right? It's important to actually know the definition of points of inflection. They happen when our second derivative changes signs, or where our second derivative goes from positive to negative or negative to positive, right? Now we have a graph of f prime. So what does the second derivative actually represent when we're looking at this graph? Well, the second derivative will represent the derivative of this graph, which also can be represented by the slope of the tangent line at a point. So if we're looking for points of inflection, it is where the slope of our tangent line changes from positive to negative. And I can draw out the graph again, right? It's not going to be pretty. We all know I'm not an artist, but the place where our slope changes, well, from here all the way to this point, our slope is negative, right? I kind of draw it with my pen. Oh, it's negative, it's negative. And then at this point at the bottom of the semicircle, it switches to a positive slope. And then it stays positive, and then at this point up here, it goes from positive to negative. So this point at the bottom of the semicircle is just halfway between those two. And it's x is equal to 2, and this point is given to us. It's x is equal to 6. So x equals 2 and 6 are points of inflection because our second derivative changes signs. So the big thing with this question is just remembering what actually is a point of inflection, and then comprehending that when we are looking at a first derivative, the second derivative will represent the slope of the tangent line, or just the derivative of the graph at a point. So that is our final answer to part B. Now we will move on to part C. Let's check this one out. So part C introduces a new function. It says let g be the function defined by g of x equals f of x minus x. On what intervals, if any, is g decreasing from 0 to 7? Okay. And it says show the analysis that leads to your answer. Now we know that a function is decreasing when its derivative is negative. So in this case, g prime would have to be less than 0. So if I took the derivative of this function, I would get g prime of x equals f prime of x minus 1. And I want this to be less than 0, right? So if I were to add the 1 over, I would get f prime of x has to be less than 1. Now looking at my graph once again, it's less than 1 all the way up to right at x equals 5. Because at x equals 5, f prime is equal to 1. So our interval where it is decreasing would be from 0 all the way to 5. because f prime of x is less than 1, so g prime of x is less than 0. And that would be our final answer to part C. So, not super difficult. I feel like that one was very reasonable. Yeah, so that's our final answer. One thing I will note, in the 2022 exam, if you go to their scoring guidelines, they say that the correct answer is from 0 to 5, but it includes the bounds, right? It's a closed interval. I would say that that is incorrect because at that point, g prime of x is equal to 0. It specifically at x is equal to 5. So therefore, our function cannot be decreasing because its rate of change is 0, right? So it's like it cannot be a decreasing function at that point. So therefore, I would put the open interval on both of these. That might have been a small slip up on their end, but just wanted to clarify that if you looked through the rubric. Let's move on to part D, which is only worth 2 points actually, which is kind of low. Normally part D is like the biggest part, right? Normally the most difficult. We've definitely seen it if you've been looking at the other questions in the 2022 exam. Part D of number 1 was pretty difficult. And part D of this last one, they were both related rates questions. Actually, I'm sorry. Part D was not a related rates question for number 1. Part D for number 2 was a related rates question. I thought that was really challenging. This one only worth 2 points. Maybe it's a little bit easier, but let's check it out. It says for the function g defined in part C, find the absolute minimum value on the interval from 0 to 7. It says justify your answer. Well, the great thing is we already know g of x is equal to f of x minus x. And absolute minimums, there are only 2 places where they can happen. The first one is at endpoints, right? And the second possibility is at relative minimums. Now our endpoints to this are just 0 and 7, right? Those are the endpoints of this interval. Now our relative minimum is going to happen where our derivative goes from negative to positive. Now if this is g of x, we already saw that g prime of x equals f prime of x minus 1. So to find the relative minimum, I could figure out the critical value where this equals 0, where f prime of x is equal to 1. Well, that happens at x is equal to 5. And at x is equal to 5, right, that's where my derivative is 1 based on the graph. F prime of x minus 1 will go from negative to positive. So my relative minimum is 5. So now using the candidates test, I'm going to test all 3 of these points. I'm going to find g of 0, g of 7, and g of 5. Now g of 0 is equal to f of 0 minus 0. Just using this f of x minus x. If we go all the way back to part A, we actually solved for f of 0. We said it was 3 plus 2 pi. So g of 0 will also be 3 plus 2 pi, right? Because we're just subtracting 0. Now g of 7 is going to be a little bit more difficult because that's f of 7 minus 7. Now, to determine f of 7, we're going to have to use the same process that we did in part A, right? Where I integrate and solve for it. We'll come back to that. G of 5, they actually already told us a big piece of that as well, because we solved for f of 5 in part A. Once again, f of 5 was 7 halves. So this will give us 7 halves minus 5, which is negative 3 halves, right? But now let's talk about f of 7. So to solve for f of 7, I already have f of 5. I know it's equal to 7 halves. It's the closest value we have to 7. But it is a trapezoid. Let's go from 4 to 7. That shape will work out the best for us. It's f prime of x dx. We know that's equal to f of 7 minus f of 4. This area of the triangle, it'll be, we have that first triangle. If we were to split it up, it'd be 2 times 2 divided by 2, which is just 2, plus the area of that trapezoid that we get over the interval from 6 to 7. It has bases of 1 and 2, a height of 1, so its area is 3 halves. And that is going to be equal to this f of 7, which we do not know yet, minus f of 4, which they tell us is equal to 3, right? So solving this, we get f of 7 is equal to 3 plus 2, which is 5, plus 3 halves, which is 13 over 2. So g of 7 is 13 over 2 minus 7, which is negative 1 half. So comparing these three candidates, our absolute minimum value will be negative 3 halves. And that would be our final answer to the question. Now, this is how I would do this, like very heavy calculus, heavy algebra driven, but I want to talk about this conceptually, right? So first off, g of 5, right? We solve for it, we get its negative 3 halves. It happens to be the absolute minimum in the end, right? But we do also know that it's a relative minimum, right? Now, on the right side of x is equal to 5, so like from the interval from 5 to 7, g prime of x, which is f prime of x minus 1, is always positive, right? From 5 to 7, f prime of x is always greater than 1, so f prime of x minus 1 will always be positive. So when I integrate, right, from like 5 to 7, I'm going to get a positive value. So therefore, g of 7 is going to be greater than g of 5. Now for 0, it's kind of the opposite, right? Because from 0 to 5, our function is decreasing, right, over that entire interval, because f prime of x minus 1 is always negative from 0 to 5, we know that g of 0 is going to be greater than 0, than g of 5, right? So we can think about this question conceptually. They kind of offer that as a solution in their rubric. I like doing it through the candidates test though. It might take a slightly longer amount of time, but I really like kind of going through this process. To me, it's easier to replicate. You don't make as many mistakes. So I'm a big fan of going for the candidates test. But that's all we got for part D. Thank you guys for watching. I really appreciate all of y'all's support, and I will hopefully see you in the next video.